Okay, welcome back to math class, and welcome to chapter 10. In case you hadn't already looked at your book, chapter 10 is all about circles. And I know what you're thinking, I know what a circle is, but unfortunately it's going to get a lot more complicated than just what a circle is. If we're starting there though, a circle, it represents a set of all of the points equidistant from a center. So basically you have a center and it's all of the points that are the exact same distance from that center. Obviously, it's not perfect because I'm not perfect and I can't draw perfect circles, but you get the idea. A radius is a line that goes from the center of the circle to the edge of the circle. This is a radius. I guess while I'm at it, this is the center. A radius goes from the center to the edge. A chord goes from one edge to the other. So it's a line that goes from one edge to the other. We call that a chord. A diameter is a chord. It goes from one edge to the other, but it has to go through the center. So a line that goes from one edge to the other edge, passing through the center, is called a diameter. Now when we're looking at all of these things, you'll notice since the radius goes from the center to the edge, and the diameter basically goes from the center to the edge twice, our formula for the diameter is going to look like, well, I'll use a lowercase d. Our formula for the diameter will be 2 times the radius, because it's essentially like making 2 radii. Conversely, if I wanted to find what the radius was and I had the diameter, my radius would be if I solved this equation for r. So it would be diameter divided by 2, or you could also say 1/2 times your diameter. Makes pretty good sense so far. Let's try an example. I'm going to rewrite those up here at the top. Diameter equals 2 times your radius. So radius equals diameter divided by 2. Okay, so now if I have a circle, here's my center, and I gave you a diameter and a random radius. So I said we'll call this A, B, C, D. Those are those points names. Now if I told you that AB, well, just if I told you that the diameter of this circle, so the diameter of this circle is 10, the diameter is 10, and then I asked you to find CD, what would we do here? Now looking at this, I can tell that CD is a radius and that AB is my diameter. So my diameter is 10, i.e. this whole area is 10, and I know that my radius is going to be 1/2 of my diameter. Then all I have to do is plug 10 into this equation. I can either do 10 equals 2r, so r equals 10 divided by 2, which we all know is 5. Pretty straightforward. Hopefully you guys pick this up pretty quickly. One other thing I should note before we move on is that if you remember back to your definitions of similarity and your definition of congruence, when we were doing triangles that were similar had the same proportions, but not the exact same measurements. And triangles that were congruent had the same proportions and the same measurements. With circles, every circle has the same proportions, no matter what. So every circle is similar, but obviously some circles are bigger than others, so they have different measurements. I'm going to say that again. Every circle is similar to each other because every circle is going to be a circle. It's going to have the same amount of degrees. And all of these things, these equations are true no matter what size the circle is. So every circle is similar. How you tell if circles are congruent is they will have the same radius or the same diameter. So if I wanted to find a circle that was exactly congruent to this circle, I would just find another circle that had a diameter of 10 or a radius of 5. Sound good?